Hello everyone. Last time we learned about the Nyquist sampling rate, that it is the minimum sampling rate that you can retain all the information of the signal. And the Nyquist sampling rate is defined to be twice as much the maximum frequency of the signal that you are going to sample. What we are going to do now is to give you some examples on how to find the Nyquist sampling rate. In the first example, we have a signal XAT, which is an analog signal. Let's say that it's equal to 5 cosine 1000 pi t, and then added with 10, perhaps sine 15,000 pi t, and then add some DC component, 15. So in this case, what we are trying to do is that we try to find the Nyquist sampling rate. The Nyquist sampling rate is can be found by finding the maximum frequency. When you notice this signal here consists of three components. The first component has the frequency f1, which is equal to 500 hertz. Okay. And here the omega is 1000 pi, therefore f1 is 500 hertz. The second one, you have the frequency f2, 15,000 pi divided by 2 pi, therefore is 750 hertz. And the last component is the DC component, therefore F3 is equal to 0 hertz. So if we use the formula, we will see that the Nyquist sampling rate can be found from twice F max. And F max in this case is the maximum between these three frequency components. So maximum of 500, 750, and 0. So the result will be 2 multiply 750, and you get the answer 1500 hertz. But in the sampling domain, we do not call it hertz, we call it sample per second. So the Nyquist sampling rate is 1500 sample per second. So let's go to the next example. In the second example here, I have the signal XAT, which is a product of two sinusoid. Okay, so let's say the first one 12 cosine 400 pi t. And the second one we have cosine 600 pi t. If you remember from principle of communication class, multiplying of two cosine is actually called modulation. This modulation, you can use trigonometric identity and reduce them into just a sum. Okay, so here it will be 2, so therefore it's 1 over 2, so it's 6 cosine A plus B, so 1000 pi t, cosine A minus B. Okay, so you get cosine 200 pi t. Again, you get two signal component. The first component f1 equal to how many hertz? 500. And the second one, you get f2 omega equal to 200 pi divided by 2 pi, so you get f equal to 100 hertz. From these two, you will see right away that we can find the Nyquist sampling rate to be twice f max. Okay, so that means maximum between f1 and f2, so 500 and 100. The answer is therefore equal to 1000. What is the unit? Not hertz, it's sample per second. In the last example here, I will not give you a simple one like I shown, okay, but this time I give you graphically. Okay, so XAT is an analog signal where the spectrum, okay, spectrum, remember, we come from the Fourier transform. Okay, so the Fourier spectrum is given by something like this. Okay, so here we give you a spectrum of the analog signal rather than giving you the equation of the analog signal. So let's say that the spectrum look something like this. Okay, here we have the key frequency. Okay, let's say this is the spectrum of the analog signal. We call XA omega. And the maximum here, let's assume, okay, so that the frequency here is 1K 2k, 0, minus 1k, minus 2k. And the spectrum height is 1, okay, like so. So by looking at the spectrum, it's quite easy to determine the maximum frequency. Right away, you look on the farmost right-hand side, okay, you see that the spectrum exists until the frequency of 2000. Okay, so here right away, you know that F max is equal to 2000. Okay. 2000 here, let's say that I forget that this is the pi radian per second. Okay, and therefore the maximum frequency is 2000 pi divided by 2 pi. So the maximum frequency is 1000 hertz. And therefore, if you want to find the Nyquist sampling rate, is twice as much. So it's 2 multiplied by 1000, and therefore it's 2000 sample per second. I hope in this lesson you understand more about how to find Nyquist sampling rate, and you could do more of this kind of example in the exercise that I will provide after this clip. Goodbye.